So here we have one of our grand trees of the Cupressaceae family, and in fact, one of just 3 species in the subfamily Sequoiadendron, which makes up our redwoods. So this is our Sequoiadendron giganteum, or giant sequoia. And the Sequoiadendron giganteum can grow up to 200 to 300 feet tall, so almost as tall as your Sequoia sempervirens or coast redwood. It's found in a very, very small range, so its native habitat is in the Sierra Nevada mountains of Central California from about 5,000 feet to 8,000 feet. And part of the reason that it's found in this particular range is because it also relies on being fairly close to the fog belt to use some of the moisture from the fog to supplement the moisture being taken up by the roots. So there are actually air roots especially some of the taller trees that can take in some of the moisture from the fog. In terms of key identifying characteristics, there are 2 types of leaves that you can find on your Sequoiadendron giganteum. They can either be scale-like and oppressed to the twig, and that's typical of your older leaves, or they can be all-like and a little bit more spread out, especially when they're young. So when they're young, they'll be all-like, fairly spread out, and then as they mature, they become a little bit more scale-like and oppressed. Each one of these scales often comes to a fairly sharp point as well. So if you grab hold of the Sequoiadendron giganteum and try to run your fingers up the stem, you'll feel those points versus if you run them down the stem. So the leaves on the Sequoiadendron giganteum will persist for about 4 to 5 years. When they do start to die, they'll sometimes hang on the tree for a little bit longer, and then when they fall off, they typically fall attached to the twig, so they fall as one complete unit. The cones on your Sequoiadendron giganteum are also really interesting. So compared to our other redwood species, such as the Sequoia sempervirens or your Metasequoia glyptostroboides, which is the dawn redwood, these cones are anywhere from 2 to 3 inches in length, so quite large. They're fairly egg-shaped, and the scales are fairly wrinkled but hard. These cones are also extremely interesting ecologically. So they're typically born high up in the tree. They take about 2 years to mature. A single mature tree can bear up to about 11,000 cones. That's a lot of cones in one tree. For these cones to open, though, it requires several different factors. So these are sometimes considered serotinous cones, meaning that they will open with agents such as wildfire. So when wildfire dries them out, that vascular supply is cut off. Then they open, and especially in a wildfire, it will burn off some of the humus, remove some of the competing vegetation, and open up the ground for new Sequoiadendron giganteum seedlings to mature. Interestingly, we often think of beetles and trees as not getting along very well, but there's a species of beetle known as the longhorn beetle that will actually lay its eggs in these cone scales, and as the larvae emerge, it cuts off the vascular supply and will also sometimes help to open up these cones so that they're able to germinate. So pretty interesting that a longhorn beetle actually can help to open our cones. The bark of the tree is also very, very interesting. So towards the base of the tree, the bark can be anywhere from about 12 to 14 inches thick. So that's more than a foot thick at the base of especially our more mature trees. It's very fibrous and spongy, which also makes it very resistant to fire. So this tree is very well adapted to fire. It likes having fires come through the area, clear the competing vegetation, helping to open the cones in this soil that's then prepared for the new seedlings. From an ecological standpoint, this is also a really important tree because When you have a tree that produces 11,000 or so cones, those cones also provide a food source for squirrels, birds, and a lot of different small mammals. Some people also consider this to be the largest tree by volume. So keep in mind your Sequoia sempervirens can grow taller. It can grow up to about 375 feet versus the 300 feet of your Sequoiadendron giganteum. But this one is considered the largest tree by volume. One of the largest specimens currently known is the general Sherman tree. And that particular tree is about 275 feet tall, 32 feet in diameter. So you could have a whole group stand around, arm to arm around this tree. Incredible, 32 feet in diameter. That makes it about 600,000 board feet in one tree. And that tree is anywhere from 3,000 to 4,000 years old. So it's a really, really old tree, a very special tree. But you can see why a lot of people during the time of the California gold rush thought that these would be great trees to come and harvest. And in fact, when they were first described, a lot of people back in places like Chicago thought that couldn't even be real, that no tree could grow that big in stature. The problem is when they came and decided that they were going to log the Sequoiadendron giganteum, they would cut them down. You try to imagine this 300-foot tree falling. Well, they were losing about 50% of the tree just to it shattering and breaking. So the wood is very durable, it's very rot resistant, but it's also fibrous and a little bit brittle too. So when you have it falling from great heights, they were losing a lot of that merchantable timber. They would try to do things like dig a big ditch and line those ditches with boughs to cushion the fall of these huge trees. But even so, these trees, which were sometimes sold for shingles and fence posts, sometimes ended up as just matchsticks because of how brittle the tree was. Again, the key identifying characteristics are the leaves, which are scale or awl-like, and often have those fairly sharp points on each scale. And then these cones, which are anywhere from 2 to 3 inches in length, cone-shaped, very, very hard scale. So I'm squeezing this cone. Those are fairly durable scales. They don't break open very easily.